from my class, and he'll be giving a digital presentation. He's from Fort Collins, Colorado, is majoring in mechanical engineering, and he aspires to get better at using a slide ruler. Fun fact. Take it away.
Yep. So, yeah, hi, I'm Quinn. I'm definitely not nervous or anything. And so today I'm going to be presenting on the art project that I did for my colloquium class. The project is called Random Dots and Less Random Dots, the reason for which will shortly become clear. So I want to start by showing you all a shape. Specifically, this shape. This shape is the Sierpinski triangle, and it's probably my favorite shape. Now, very sadly, I don't have time to explain why this shape is so cool right now, but seriously, you all should look it up when you get home. I will be disappointed if you don't. But for now, just take my word for it that this is cool. And remember this shape, because we will soon return to it. So, if you couldn't tell from this little introduction, I'm a nerd. I love math science stuff. So, I was really excited to read this book by Carol Rovelli. This book is called Reality is Not What It Seems, and in large part, it's about quantum theory. Now, to the best of my limited understanding, the idea in quantum theory is that if you zoom in far enough, everything becomes probabilistic. So, for instance, if I have a particle, I can't say the particle is here. All I could say is something like, if you look here, there's a 30% chance that you'll see the particle. So, in that way, the universe is really random. If you look in this spot, I can't tell you with any certainty whether or not you're going to see the particle. It's random chance. All I can tell you is the percentage of that chance. And this is really weird, right? Because we look at the world around us, and we usually feel like it's based on order. We tend to think of order as being fundamental to the universe. But then quantum theory comes along and says, no, the world isn't based on order. Order isn't a fundamental property of the universe, it's an emergent property. Order is something that emerges from quantum randomness. So, anyway, all this reminded me of a YouTube video. Of course. The video is specifically from the YouTube channel Numberphile. I don't know if there's any Numberphile fans here. They're good. You should look them up too. You have homework, remember that. So in this video, and I promise this is all going to somehow end up being related by the time I'm done talking, so bear with me. In this Numberphile video, a mathematician draws 3 dots, labeled 1, 2, and 3. And he also draws another random dot somewhere. And then he generates a random integer between 1 and 3. So basically, he rolls a 3-sided die, or dice, whichever you prefer. So he rolls this 3-sided dice, and if it comes up, for instance, a 2, then he goes halfway to point 2, and he draws another dot there. And then he rolls the dice again, and let's say this time it comes up a 1. So then he goes halfway from the point he just drew to point 1, and draws another dot there. And he keeps rolling the dice. He keeps repeating this process thousands and thousands of times using a computer program until eventually he gets this. It's the Sierpinski triangle. He's just made my favorite shape using random numbers, which I think is just so cool. And I don't know, this process kind of has the flavor of quantum theory, because this is order emerging from randomness. So this is where I come in, because I read Rovelli and I was thinking about this video, and then I thought, what if I did the same thing as the guy in the video, but instead of using random numbers, I just made up a bunch of numbers that felt random to me. Now, I know that humans naturally gravitate towards patterns, so I figured that my numbers would have some order kind of lurking in them, even though they felt random to me. And I wondered how that hidden order would affect the image. So to find out, I made up a list of 1,000 numbers, and I grabbed paper and a pen and a ruler, and then many hours and several podcasts later, I had this. And I think this picture is really interesting, because you can see how it's sort of trying to become the Sierpinski triangle, but it's like something's gone wrong. It's all clumpy. It looks similar to the one in the video, but it's not nearly as well structured. So then I thought, okay, maybe I'm just bad at drawing these things. What I need is a control. I need to do this whole thing again, but this time use truly random numbers and see how it turns out then. So I did that, and I got this. And this time, it looks exactly like the picture in the video. So what that means is, the reason it came out badly the first time is just because my random numbers weren't really random. The hidden order is what messed up the first picture. So, as silly as it kind of sounds, I feel like, I'll wrap up here because I'm out of time, but as silly as it sounds, I feel like this little experiment kind of gives a glimpse into how the universe works. Because when the drawing was based on randomness, we got this beautiful structure. But when the randomness got contaminated by order, the structure didn't form properly. So for me personally, I feel like I have a better intuitive sense now of how order actually can't exist without randomness. So I will leave off there. Thank you very much.